I'm sure after listening to Dr. Ju's presentation, all of you are very much motivated to pursue a career in space medicine. And you might have questions on how to navigate your career path as a student, how to get involved in space medicine. And for that exact purpose, we have Ms. Jiho Yun with us, who will present her career pathway so far and give you an inspiring example of how, as a student, you can get involved in this wonderful domain of space medicine, how you can reach out to supervisors and professors like Dr. Ju, and how you can utilize all the resources and opportunities available around you to create your pathway. So, I welcome you, Jiho, to our webinar, and thank you so much for accepting the invitation as well. I would quickly go ahead and introduce Ms. Jiho Yun. So, Jiho is a first year medical student at Sung Kyung Kan University School of Medicine. Please pardon me if I'm pronouncing the Korean words incorrectly. And she has a keen interest in space medicine and interdisciplinary research. And today she is going to present to all of you her career path, her experiences so far as a young enthusiast and young professional in the domain of space medicine. And I'm sure you would have an inspiring audience to Jiho's career path, and it would also open up new horizons and new boundaries for you to explore this interesting and exciting domain and field of space medicine. So please give a big round of applause for Ms. Jiho Yun, and we are extremely happy and proud to host you today in our webinar. Over to you, Jiho.
Okay, thank you so much for introducing and also providing this honorable opportunity. I actually had some questions to Professor Jihyun-ju, but maybe due to time constraints, I can go over my presentation and do the questions together. So, okay, I'll share my.
You can also go ahead and or ask Dr. Ju if we don't want to keep him waiting for long. So maybe we can have the question right now as well.
Oh, no, it's okay. Yeah, I will. I can wait and to end of the Jiho Yun. I am
Thank
also
you.
interested in her talk. So
Okay, perfect. That's perfect.
Thank you. Can I introduce myself in Korean first, if it's okay?
Yeah, please feel free.
네. 네. 안녕하세요. 저는 성균관대학교 의과대학 이사학번 윤지호라고 하고요. 지금 보시는 사진은 제가 좋아하는 밴드 활동을 하는 모습인데요. 그냥 제가 이렇게 우주의학에 대해서 발표하기 이전에 그냥 사람으로서 세상을 바라보는 방식을 보여준다고 생각해서 이렇게 사진을 가져와 봤습니다. 물론 오늘은 우주의학을 주제로 발표하게 됐지만 뭐 음악, 의학, 인공지능, 문학처럼 되게 다양한 분야에 관심이 많았던 평범한 학생이었고 그리고 오늘은 발표 내용을 학술적으로 할까 고민하다가 이제 교수님께서도 발표해 주시는 만큼 저는 우주의학이라는 걸 처음으로 접하는 사람들이 어떻게 진로를 구성해 나갈 수 있을지를 중심으로 얘기를 하고 싶어서 이제 그런 부분을 담고자 노력을 했습니다. 그래서 저는 오늘 그런 저의 시선으로 우주의학을 어떻게 시작하게 되었고 앞으로 또 어떤 미래를 꿈꾸는지 같이 나눠보도록 하겠습니다. So, let me now switch to English to share my story with broader audience today. So hello everyone, my name is Jiho Yun, and I'm currently a medical student at Sungkyunkwan University in South Korea. So to be honest, I'm not your typical med student. So I started out studying literature, writing short stories and novels. Then I found myself stepping into medicine. And currently, now I'm juggling lab experiments, soldering circuits in a rocket team, and even chatting with astronauts about healthcare in space. So for a very long time, I thought my scattered interests and inability to focus on one thing was a weakness. But now I realize it's a strength because space needs people who can connect different worlds. And that's exactly who I want to be. So I know there are people here with far deeper knowledge about space and those who have built incredible careers. And I have seen from the chatting that there are not only medical students, but also people who majored in business or different sectors. So I'm just a student who hasn't even taken core courses, and my research is in beginning stage, but I'm here to share one simple truth. Space isn't just for those who already know it all, but it's for those who are willing to begin. Okay. So, what made me start space medicine? Back in high school, as part of a cross-disciplinary project, I briefly explored designing a negative pressure ward for space, like just a hospital. So it was an exercise to think about how medical care could adapt in a completely different environment, a confined spacecraft where infection control is very crucial. Though it was a very short project, it sparked my curiosity about space medicine and the challenges of healthcare beyond Earth. I thought if Earth needs hospitals, space will need them too. And if Earth so I spent my high school to KAIST, a engineering school, to aerospace engineering department, and was accepted for an early admissions introduction program. And this was the lecture that I saw. So, but when I saw the complex physics formulas, I realized it was not for me. So at least not yet. Hmm. Um, yeah. So taking a break from school due to different issues, I tried again by joining the Aerospace Medical Association of Korea and attending their conference. However, most talks were about aviation rather than space medicine. So then I joined the Rebrand Academy, hoping to learn more about space, but found it was mainly focused on personal branding and social media skills. Still, I had the chance to meet inspiring people like Sania, Stephanie, and Banan, who were NASA engineers, astrophysicists, space law experts, CEOs, and designers shaping the industry, and who became my mentors and supporters of my first step to space. Among them, there was my buddy Theo, who encouraged me to join SGAC, which became a pivotal step in my journey. So I joined many networks like SGAC Life Sciences and Space Medicine Project Group, Women's Aerospace Network, and more. So while reading inspiring opportunities in our rebrand cohort, I applied to the world's biggest analog project, originally as a volunteer, but I ended up as a crew after passing online application. So analog mission is trying to create a similar environment in Earth, like in space. So, for example, in a desert or a underwater condition, they form a habitat and they do mission for like 2 or 3 weeks to actually prepare for after space missions. So, however, I'm still a student, so I wasn't able to participate in in-person training, but there were some team projects and classes that helped me learn more about analog missions. So around the same time, while doing big data and AI research in my lab, my professor asked me about my dreams, and I talked to him about space medicine, and he encouraged me to pursue space medicine. So that led me to start research on space omics through SOMA and other open databases. So all these small experiences helped me to apply to the Space Generation Fusion Forum, which was very reckless and a big challenge for me. So initially, I was waitlisted, and I even had failed ideas for other competitions. And also today, I think Marcus talked about EPD and other education platforms. I also applied for those, but didn't get accepted. But eventually, I got accepted to SGFF finally and went. So at SGFF's Space Symposium, I met many incredible people. I was just a high school graduate with nothing extraordinary, but through this event, I was able to build a valuable network. So I attended NASA breakout sessions, connected with exhibiting companies, and formed not only professional relationships, but also lifelong friendships with my roommates and many wonderful delegates, panelists, and volunteers. So during one panel talk during the sessions, I asked questions to Korean space company's CEO. And unexpectedly, I was invited to a reception hosted by Boyoung, a Korean pharmaceutical company, which had their recent transition from just basic pharmaceutical research into space medicine industry. So they even kindly invited me to visit their office later. So after returning to Korea, they featured me in a Space Talk interview, and I had the opportunity to talk more about this industry with their representatives. So after returning to Korea, I have worked to activate Space Generation Korea, collecting contact from previous national point of contacts, attending ISS 2025, and meeting many people, deepening ties with SGAC contacts. So actually, last week in Korea was first artworks being presented in the International Space Station because of Humans in Space Use event. So it was a very record-breaking event. So all of these led to incredible opportunity to present here as the SGC Mentoring Committee session. So I think as I only invested like 1 or 2 few years in this journey, still you can develop much and build concrete steps towards space medicine. So yeah, I think this question came out quite late, even though it's a space medicine webinar. There is one way I used to describe space medicine to other people. Usually, people are not familiar with the concept of space medicine. So when I say I want to pursue space medicine, my friend also asks, so now you want to cure aliens and treat like people from Mars? However, space medicine can be understood in two major ways, I guess. So, first is protecting human health in space. So, as more civilians and professionals travel to space, space medicine plays a critical role in ensuring their physical and mental health before, during, and after flight. So, this includes the understanding the effects of microgravity, radiation, isolation, and also re entry back to Earth on the human body. However, people might not be much interested if it's only for astronauts. Um, Second part is introducing new paradigm to medicine in Earth, like Professor Juice. So the extreme conditions of space serves as a natural laboratory that pushes innovation in diagnostics, telemedicine, AI-assisted care, and also personalized medicine. So these advances often circle back to Earth, offering new paradigms for healthcare delivery and biomedical research. So when I first looked into space medicine, it was simply because it sounded very interesting. But as I dug deeper, I found real open databases like NASA's Space Omics and Medical Atlas, and so the
Yeah, now we can hear you again. Sure.
Okay.
Yeah, all good.
Mm, okay. So, can I start again from this part, or is it does it
Yeah,
work?
I guess from this slide would be good.
Okay. So So now let's talk about what we actually study in the field of space medicine. So space is a completely different environment. It affects our bodies, minds, and even our genes in ways we don't fully understand yet. So that's why researchers have identified a range of critical topics, like I just wrote some of them, and it will be more important as spaceflight becomes more accessible to civilians. So some of these topics include musculoskeletal atrophy, neuroocular syndrome, or disruption of circadian rhythms, immune system, and DNA damage. But we also need to think beyond the body. For example, how do astronauts maintain psychological resilience in isolation? Or how can we monitor cognitive performance and group dynamics in a confined crew? Or how do we deliver medical care autonomously when help from Earth is not available or very limited? So we are also seeing new frontiers in pharmacology. As Professor said, I think proteins crystallize better when they go to space, and this might lead to better drug screening and also advances in wearable devices, especially AI-based health prediction is very developing. So all of these shows how space medicine is a truly interdisciplinary field. Yeah. So yeah, ClinStat was already introduced, but so like how do we actually study these stuff before actually going into space? So there are several innovative methods used to simulate space conditions here in Earth. So since ClinStat is already explained, there are other two examples. First is analog missions, which are conducted in a remote, isolated environment like deserts or underwater stations, so where we can mimic long-term confinement. And also there is something, the concept called parabolic flight, and it is already done by a company called Zero G, which allows short terms of microgravity for real-time experiments by following a certain path for a flight, which can generate microgravity. So these tools allow researchers to test their hypotheses, refine their methods, and ensure that real missions must be safe and effective. But to truly advance this also needs something else, which is data. So open, high quality, and shared data is very needed because one of the biggest challenge in space medicine research is that currently there are very limited people who can get access to actual space for now. So these are some of the examples I wanted to introduce. First is SOMA, which brings together multi-omics data from space flight missions to build a comprehensive biological reference. And also OSDR, which also contains space medicine related data, but it's not limited to humans, but you can also get plants or murine and more data. And also there is Life Sciences Data Archive. So I have tried data analysis with the SOMA database, and it is a very interesting database to look at because it contains data from SpaceX Inspiration 4, that's the most recent, and also the NASA twin study. For your information, this study is done by sending one of the twins into out into space and leaving one twin in the Earth and comparing their genetic differences and so. And also there is Japan JOXA CFE study and also some anonymous cohorts from the ISS. So if you're interested in multi-omic study of space medicine, this database also contains transcriptomics or special transcriptomics and metabolomics data where you can get access by providing IRB. So if you're interested in getting high quality data, I think you can definitely use NASA's open database. So this is the question that I think is really important. Why should we research space? Because even though there are many data or many experiments that we can do, I think the most difficult part is to persuade people, persuade your company or persuade your laboratory that we should research space, even though we spend lots and lots of money. So even if you've never dreamed of becoming an astronaut, I think space medicine matters to you. And that's because when we study how human body responds in space, we can uncover truths about our biology that we can't learn anywhere else. So microgravity weakens bones in weeks, just like osteoporosis does over years. And space radiation is known to accelerate cellular aging, but there are many contradictory results related to telomeres and different hallmarks of aging. And also, isolation affects the mind, and also for radiation, just as it does for patients on Earth in ICUs, submarines, or remote regions. So, in short, I think space becomes a unique laboratory for understanding human health. So, these discoveries we make up there return to Earth as better treatments or smarter technologies and stronger system for healthcare. So I think the big that you can do for now is trying to make the concept of space medicine more familiar to people around you. For example, if you're a student in doing PhD or master's, you can continue presenting about these articles in your journal club or just lab meetings, trying to get feedbacks from experts so that they can incorporate their expertise into space medicine research. So these are some of the practical opportunities that you can use if you're Koreans or even globally. So in Korea, there are lab internships and projects. For example, companies like Boryong that focuses on space biotech. And there are contests like Humans in Space Challenge, where if you're a startup or researcher, you can pitch your idea and they select their teams to get their payloads actually up in the space. And you can, if you're a student, you can join university clubs focused on aerospace or space medicine and seek out opportunities to collaborate. Internationally, organizations like SGAC offer mentorship, networking, and also their different project group based on different sectors. And NASA and ESA also run calls for research proposals, challenges, and definitely internships. So my goal is to build SGAC Korea because I think we need an open, accessible network for young dreamers in Korea to enter this field. So these platforms and programs are all fantastic gateways if you're willing to start when no one else has. So if you dare to be the first, I think you'll find a way in space industry. So I'm still a student, but this is just my own personal vision after I went to Colorado Springs, United States for space symposium. So one thing I realized at SGFF is this. Space is not a place you can go alone. So even when you think about building a single rocket, it requires efforts of student teams, national agencies, and international collaborations. And also for the unknowns of space, there's legal, ethical, and also scientific frontiers are not things one person or one country can decide because they belong to the humanity. So for me, being part of the space field is not just about increasing my own knowledge, but I think what's important is to communicate with others, build shared goals, and make sure that the technologies we develop serve as the right value. So just like how AI, like ChatGPT and other AIs, has quietly embedded itself in every part of our lives, I believe space should not remain in the hands of only engineers or scientists, but it should be something that every citizen in their own way can carry in their hearts and in their personal lives. So that's why I dream of a world where people from all fields, medicine, arts, education, policy, and even engineering, can imagine how their own ideas might one day reach space. So this is a question someone asked from Space Generation Fusion Forum. There was a board of panels, and one person asked what kind of qualities we need to get successful in space industry. And then the panel replied, I think space industry needs a unicorn because you should be excellent in every part. And I believe you don't need to be a unicorn. However, these qualities are very important if you want to have your career in space industry. Being interdisciplinary and being able to adapt to numerous hazards that can happen during space missions, being able to collaborate with not only your partners but also globally, and can think systematically, seeing the big picture in interconnected space missions. And I think what's most important is responsibility. Um, Not only guided by mission for yourself, but for the whole humanity and trying to use those technologies ethically. So these are just one of my personal goals. Why do I share this talk today? Because I think space is not only for experts. So I believe that the person who dares to start for it is the one who can change the game. So my goal this year is trying to start SG Korea by launching a website or a platform and trying to build concrete programs for future years of SG Korea. And few years later, today we're doing it as online, but I hope Korea can hold offline space generation workshop. So if you also share this vision, I hope you can join me and we can build it together. So yeah, if any part of what I shared today sparked your interest, maybe you thought like this is not for me, but I still want to hear from you because first I felt the same. So space is very large and unknown, but I think if we start together, it can become a place where everyone can participate. So this is just my motto: try and fail, but never fail to try. So yeah, thank you for listening to my talk today. And please feel free to ask any questions. Thank you.